Good morning, everybody. Thank you, Jock. Early morning, I presume. When we're in lockdown, we're getting up a bit later, I presume, as well. Don't know how many guys are busy out there, but down in the Southern Cape, we are very quiet. People are sticking to the lockdown. So here we go, testing of water reticulation this morning. Not a very interesting subject, but I think something that has been neglected. I don't think has been done properly. And even personally in my company as well, we don't give too much attention to it. And I think there's a lot to be learned in this morning. So let's go and have a look at water reticulation testing. And I think very important to note is, is where do you find it? If you go to the standards, you want to know about testing of water. Where do you go? So let's take it from the top. First of all, a little back in history, up until 1977, local bylaws were governing authority as there was no common building regulations in South Africa prior to 1977. So every city and town with a municipality had a chief building inspector with inspectors and their own homegrown regulations. And in terms of the water and water reticulation testing, the information was very little, if any. So how is water reticulation covered today? So after 1977, the national building regulations were promulgated as we know it today as SANS 10400. But still, where do we find it? Is there any water testing in 10400? So in this pyramid, and you'll find this on the IOPSA website as well, this pyramid. So if you want to go back to it again, you'll find that right at the top, we have the legislation where it starts, and right at the bottom, you'll see it's got auditing of new installations, maintenance, replacement, and repair, signed off by the licensed plumber. So there we have it from the top down to where you are. So let's go and look who governs you. So first of all, we have the Occupational Health and Safety Act. And then obviously very important is the Consumer Protection Act, Act 68 of 2008. And that is where we start with legislation. That's all encompassing. So then on the left-hand side, we have the National Building Regulation, which, as I said, was promulgated in 1977. And we have all the different parts to it. And my good friend Adrian Myberg out there can recite it all out of his head. I'm not that good yet. The parts that pertain to us is part P, which is drainage. So no water reticulation and drainage. So what else is there that pertains to water in the National Building Regulation? Part W, that is installation of fire installations. So that is the only part that pertains to any water reticulation. So where is water then? We're going to look at the Water Services Act. Water Services Act is where water reticulation is placed in, but we won't find it, by going through the Water Services Act telling us how to test water reticulation. So where is it? So in SANS 10400, the National Building Regulations, B12, it says the Water Services Act 1997 enables the Minister of Water Affairs to prescribe compulsory national standards relating to consumer installations. In this regard, it defines a consumer as any end user who receives water services from a water service institution, including an end user in an informal settlement, so that it covers everybody. A consumer installation as a pipeline, fitting, or apparatus installed or used by a consumer to gain access to water services and includes a meter attached to such pipeline, fitting, or apparatus. So there we have it. Regulation 14, issued in terms of the said Water Services Act, reads as follows. There we see that they're talking about water. Then for number 14, it says every consumer installation must comply with SANS 10252 Part 1, water supply and drainage for buildings, and SANS 10254, and that is the installation, maintenance, replacement, and repair of fixed electric storage water heating systems. So we have two there. We have water reticulation and we have hot water reticulation in this one. So back to our pyramid, you'll see there on the left-hand side, SANS 10252 Part 1 has popped up, and that is applying to water. And on the right-hand side, we have SANS 10254. So they interact with each other. Those are the two ones relative to testing of water reticulation this morning. And then obviously, if we're going further down the line, we'll have SANS 10106, and SANS 1352 being solar and heat pumps. And then that is all your standards that pertain to us. And obviously there are some other sub-standards that are referred to throughout. But we're just going to look at SANS 10252 Part 1, and then obviously SANS 10254 that relates to it being hot water, so it's going to be discussed all as one when testing water. So if we go into SANS 10252 Part 1, you'll find it at page 120, very short piece on cleaning, inspection, testing, and disinfection. So it's just not testing, it's cleaning, inspection as well, and it's got disinfection as well. And that's all part of your testing. So what does it say about cleaning? And this is the sequence as it goes in the standard as well, and this is also the sequence that you will be doing it. So before a general or combined water installation is disinfected or is pressure tested for acceptance, it shall be properly cleared of all foreign matter. Note, flushing out a system with water often fails to remove matter such as non-water soluble cutting oils, corrosion products, mortar, pieces of stone, or foreign objects that might have wedged in the fitting. Problems experienced with installations that have not been properly cleaned out include poor hydraulic performance or bad taste, especially in the old galvanized pipes. If they've been cutting and that cutting fluid is in there, it can stay there for months before it really gets out of the pipes. So let's have a look at a copper pipe. When we cut a copper pipe through, this is what it typically should look like. All nice, one-colored, with the oxidization of the copper on the inside, and that is a healthy-looking copper pipe because it was cleaned after installation properly, and after a couple of years, you cut it open. That's what it should look like. But what is the problem if we do not clean it properly? We find that from fluxes, although today we have all the water-soluble fluxes, the picture at the top shows what the old fluxes were doing to it. It was really eating away at the pipes, and especially if you've been putting the pipes into the wall and then just not flushing it out and leaving it for 2 months while they build and complete the build, that is what typically was happening on the inside of the pipe. The bottom picture is put under a bit of magnification there, and that is typically called a copper rock, and that then eats and gets stuck into the copper pipe. So copper rock typically gives you the corrosion. You can see even on the outside of the pipe at the top. On the left-hand side bottom with a red arrow, you'll see the cut out, and this is one that I cut out myself, and I found that little copper rock in there, and it's stuck. And on the right-hand side, looking through the pipe, you'll see some more of them stuck into this pipe. So just hold on a second. My throat gets dry this time of the morning. All right, so this pipe gets all the copper rock inside, and it's not cleaned properly. It stays there, and on the inside of the pipe, you'll see on the left-hand side the red jagged edge and the green jagged edge. Between the two, you'll see there is the bright copper color that you can see it clearly, and that shows that it's been corroding there. The pipe has been cleaned. It's like acid. It's been cleaning it away. But on the left-hand side of the green, you'll see that is where the pitting is starting. And on the right-hand side of the red line is the normal copper color from a pipe that is being in use. So on the right-hand side, you'll see the pit mark in it. So why does this happen? Why does it give that bright copper color there? And where that green section is, that's where your copper rock was situated. It's because it's a natural phenomenon. Water is corrosive. If we look at this from Berg's Luck potholes, from you guys that have been in Mpumalanga, that's nature. Nature does this with water. It's got fine grains of sand in it, and it's very corrosive. So on the left-hand photo, you'll see water rushing through in a flooding system there, and the yellow arrow points towards that typical, like you'll have in a pipe, will be a copper rock, that solid piece of rock in the center there, and the water rushes past it. But look on the right-hand side. After flooding, you can see what the effect is. The rock is sticking up there, and through years and years, it's been corroding away, and it creates turbulence. When water goes through there, it's turbulent, and it's cutting away. So it's exactly what happened with the, if we go back to that picture, you'll see on there that bright copper section there. Those are the potholes, and that is where the water corrodes it, because the rock is creating turbulence, and the water is rushing around it the whole time and eating away at the copper. So you'll find typical what has happened here in nature is happening on the inside of your pipe as well. So cleaning it is very important. So if we go to the standard in 9.1.2, you'll see it talks about pigging. A while ago, I had one of the plumbers coming here, and the architect specified that all pipes must be pigged. And we went onto the internet and we searched for pigs to pull through this pipe of 22 millimeters. You just can't find it. So an effective method of cleaning out installations is to pass a specially designed pig through the system. A pig is usually a bullet-shaped polyurethane foam or cylinder with or without strips of harder material such as urethane rubber on its surface. It's pulled through either mechanically or pushed through by pressure. So this is typical, the diagram in the standards, and you can see we're talking about larger diameter pipes, main lines where they use pigs that go through. So pigs, the only pig that I could find available is for 50 millimeter pipes and up. So for your normal domestic 22 and 15 millimeter pipes, there are no pigs available. So we'll have to do it a different way to clean them out. But for the guys doing main lines, know that there are pigs available, and this is how you'll do it, is by pushing it through by pressure. On the right hand bottom one, you'll see it's got like a hook on it, and it'll be pulled through mechanically as well. So then the next step would be inspection. After cleaning, you inspect. Before testing, the installation shall be inspected. It says this is out of the standard. Visually, to detect faults in construction of materials for compliance with the drawings and specifications. Maybe there's a washing machine supposed to be there and the guys forgot about it and omitted it. Make sure that everything is there. You don't want to chop into a wall afterwards and adding pieces into it. And then obviously you go and check the pipe, because sometimes the guys have been through there with a wheelbarrow or something and they knocked a dent into the pipe, and that dent in the pipe is typically also where you're going to find corrosion and pitting again in your pipe. So go through it very carefully and check that everything is done properly. Note irregularities at joints, the installation of fittings and components, especially the correct fitting and installation of safety devices, protective coatings, and the supporting and fixing of pipes, fittings, and components. And here's another important part, is the lagging of pipes. All hot water piping, and this is in the standard, including pressure relief and overflow drain pipes restricted in movement through encasement in concrete or plaster, should be lagged throughout the encased length with approved flexible lagging material, and they give a reference to it. So what is this? This is typically the CXP tape, copper expansion protective tape. It's a paper, and you wrap that around your pipe. But now it says all hot water piping. Why doesn't it say cold water piping? But if we go and look, it says in the manufacturer specifications, they suggest that all pipes must be lagged. Why? Because it's a manufacturer specification. Because in the case of copper, it prevents chemical contamination of pipe surfaces. All copper tubing to be encased in cement should be lagged, and all PVC. And that comes out of a manufacturer specification. So if you're going to have a failure on the cold water pipe, they're going to come back and say, you didn't lag it. There's chemical contamination from the cement, and it's corrosive. So all pipes, copper tubings, will be lagging the walls. But what about plastics? If we go further into the standard, SANS 10252 Part 1, Paragraph 8, it says explicitly, plastic pipes shall not be rigidly encased in floors, concrete slabs, or walls. What does that mean? You can't put it in like that. You have to lag it. You've got to put it in a sleeve or whatever the case may be. In the case of water pipes like PEX piping, speed fit pipes, the Ginder pipes, all those have to be lagged as well, because you want it to prevent it from moving with the wall and the fitting. So it facilitates pipe and wall movement without having the two different materials moving as one. It prevents fracturing of solder joints and other joints, and it prevents pipes from pulling out of compression type fittings and the crimp fittings as well. So you want it to be able to move. But now I know the guys say, this paper is difficult. How do you wrap this paper? It's dry, and you put it around, then it bundles off again. So I found a very easy way to do it. I take it, I make a small little roll of it. We started from left to right. You roll it up in a small little bundle. You wet it completely, and then you wrap it. And there's it. It sticks, and you don't even have to use tape to keep it together, and it will stay there, and it's easy to wrap around with a small little bundle. So it's very easy to do. And it's quick to do, and even use it when doing maintenance, because then you're protecting that fitting again where you've done the maintenance on it. So obviously cleaning of the pipes as well is very important. All the solid joint, if it's solid, must be cleaned off as well. So thermal contraction and expansion of tubing, that is SANS 460, is very clear on that. The coefficient and linear expansion of copper tubing is about 0.0166 millimeter per meter. Example, for a 60 centigrade rise in temperature between 0 and 100, the linear expansion would be 1 millimeter per meter. Now you can think what that expansion can do to a solder joint. If it's not being able to move, it's going to crack it. And that is how we find a lot of the leaks in the walls. So the next step would be testing. So how do we do the testing? And this is what it goes about. It's the testing. And this is something that is not always being done. People just fill up the pipes, leave it like that, and you see no water, it's fine. But it should be done on the right way according to the standard. Slowly fill the installation with water with the highest draw-off point open to allow the air to be expelled from the system. And once full, check each terminal fitting for the rate of flow against the specified requirements. That's if you've put your terminal fittings on already. But if you haven't, put in a little ball valve at the end and on the separate places where you want to bleed it through. If there's long dead legs or something that you want to get the water in, check it, make sure that all the air is expelled from the system. And then we can use equipment. Rottenberger makes them, and Rigid is the green one, the bottom. And this is the instructions of how it's being done. Comes out exactly. It says slowly fill the system, walk around the system, check for leaks, leave it to stand for 30 minutes, attach the hydraulic pressure tester, and they all work on the basic same principles. You even get electrical ones as well. Pump the system up to 1.5 of the working pressure. Leave the pressurized for 1 hour, check for any drop in pressure, and rectify any leaks. So that is that's exactly what the standard says. So the standard says testing water, fire, or combined. So unless otherwise required, subject any water installation other than a fire installation or combined installation. Combined installation, that means where you have fire and normal domestic line in one combination, to a test pressure of at least 1.5 kilopascal, but not less than 1.5 times the maximum working pressure of the installation, and maintain such pressure for at least 1 hour. But if you have now a combined system and or just a pure fire installation, a test pressure of at least 2000 kPa, but not less than twice the maximum working pressure of the installation, and once again, at least for 1 hour, and there must be no drop in pressure. So make sure if you've got a combined installation that you use the one in subparagraph B. So the next step, we have had cleaning, inspection, test, pressure testing, disinfection. When any extension or modification has been made to a water installation on any premise separately occupied or any private dwelling that has its own separate service pipe, then that water installation shall immediately before being taken to use be thoroughly flushed with fresh water drawn directly from the mains. So disinfection, the next step, and this we'll find that they talk about storage tanks there. Apply the following disinfection procedure to any storage tanks. We'll see later towards pipes, how they disinfect pipes. You remove all visible dirt and debris from the inside of the storage tank. The same procedure. Check that everything is clean. Fill the storage tank with clean water and then drain it until empty. So now you've done the cleaning of the tank. You refill the storage tank with clean water and add a solution of sodium hypochlorite to the water until a free residual chlorine level of 50 milligrams per liter in the water is measured. That's quite easy. You can weigh it off and the capacity of the tank, measure it, and you know exactly what the level should be. Leave the chlorinated water in the tank for not less than 1 hour and not more than 3 hours, after which in turn open each terminal fitting served by the storage tank, starting at the closest one to the tank and working progressively away from the tank until the water discharge begins to smell of chlorine. Then close each terminal again, and then you can let it stand, because now you know you've got a chlorine mixture throughout the pipe, throughout the tank system, and it can stand there to disinfect it. So how do you chlorinate a pipe system? You use something typical, these big blue filters. You put one like that into your line. You don't have to leave it there, obviously. You can take it and reuse it every time, and you fill up the blue canister with your chlorine, and you put it back, and you flush water of that quantity through, and you refill it, and you continue until all your pipes are filled and all the chlorine is starting to come out from all the different terminal fittings. And you know you've got it in your system, and you leave it standing for that 1 hour period. Sorry, it's a 3 hour period. No, I'm correcting myself here, for at least 24 hours. Carry out the chlorination treatment, at least 20 milligrams per liter on pipes, and leave the chlorinated water in the system for at least 24 hours, after which flush the system with clean water. A note here is to make sure that your pipes are compatible with that sort of chlorine that you are going to use. So check your manufacturer's specifications. If they say don't use anything like chlorine, or if they've got something specific, then use that product. And the same would be for plastic pipes as well, because now remember, you want it to be disinfected because of Legionnaires as well. So you do that in the same for plastic storage tanks. Keep the tank and pipes charged with the chlorinated water for at least 16 hours, and then thoroughly flush them with clean water. So the sequence of testing water reticulation, we've had it there. First, you clean it out, check it for debris, anything. You do the inspection, check that you have done it according to this, the plans. You look for dents and dings in the pipes or bad connections. And then you put up the pressure test. You pressure test it and leave it standing for 1 hour at least. And then you disinfect it, and then you hand it over to the client. And that is the procedure. Are there any questions this morning?
Yes, Marius, we have some questions. So for the first one, why don't plumbing suppliers sell brown paper as they used 2 years ago if it is in spec?
I do find that CXP, the paper, is being sold locally here in our shops. I don't know why the others don't have it. I know the Plumlings and on taps are selling it here in the Southern Cape, so it is available. So they could just check with their suppliers. It will be available. They must just ask for it.
Okay, the next one. Never seen this done in 30 years, and who is going to cover costs if a plumber for this, and what are the costs of doing this?
Well, it's not, as I said, yeah, we are neglecting it, and it's you most probably have never seen it, but this is what the standard stipulates, and this is how it should be done, because we have various different pressures, and I think the thing why guys haven't been doing it is like where I live specifically, the municipal pressure rushes up to 9 bars. So yes, you have much more than the working pressure. So the guys are neglecting on pressure testing because they are they know that the pressure is very high, so they don't test it. But this is what the standard says how it should be done. So if you do an installation and something does go wrong, and you haven't done it properly, then obviously you'll be held liable for this, and it could cost you a lot of money in the end. So this is what the standard says, and this is how it's supposed to be done. The cost is obviously for your own account, and this is why you're a plumber. You've got the standards, you've got to follow them, and you've got to make sure that this is added into your cost when you are doing the quotation. So it's not going to be a sort of add-on cost once you've finished done the quotation. You must put it into your quotation. That is part of the job that has to be done. And this doesn't take long. The pressure test equipment is going to cost, it's part of your tools. So it's going to cost you an hour's time to fill up the water, put it under pressure for an hour, and it stands there, and then it's done. Everything is done. Disinfecting it, very easy to do. You can buy yourself one of those filters, and you can disinfect it. Although our water differs from municipal area to municipal area, so some of the municipal areas will have a high chlorine content. So you can go and check what the chlorine content is with your local water services department. Maybe it's good enough to disinfect by just having the water in it itself, but make sure that you have cleaned it out properly, pressure tested it, and that it's disinfected, because that is part of the standard, and that must be done.
Next one, how does one discard the chlorinated water?
The chlorinated water is just you just flush it out. It's not an acid, it's chlorinated water. It's like normal water. It's just with a slightly higher content. And then obviously, once you flush it out, it's gone, it goes down the drain. It's not an acid content, and it won't kill you even if you taste it. So it's just a higher content of chlorine, that's all.
If I lag the PEX pipe, are you allowed to install in concrete floors?
If you're putting it in concrete floors, it states clearly that it must be sleeved. In other words, you must be able to remove the pipe, pull it out, and push it through. So that is how it must be done in floors. In walls, obviously, you cannot pull it through. So in walls, you will be putting it into the brown paper. But when it goes into the floors, you'll be sleeving it so it can move. And there's a diagram, and it shows specifically how PVC pipes should be put into floors and gone through. I know that some of those plastic pipes are being used for underfloor heating, and that is totally a different application and is done in a different way, and it's not really part of our standard. And they are encased in concrete, but that is underfloor heating and not really part of our standard. But when it's water reticulation, it must be sleeved, and those plastic pipes are easily sleeved with these electrical conduit pipes. You can place them through that, and some of them can even bend inside those conduits, and they can be pulled out again. So if there's something goes wrong with the pipe or something, it can be loosened at the fitting, pulled out, and another one can be pushed in. So yes, they must be sleeved.
And then next one, how do you clean 15 to 28 millimeter pipes?
15 to 28 millimeter pipes will just be by flushing it out properly with water, and then obviously by disinfecting it. There is not a pigging system for that. As I said, I've really researched it. I couldn't find. If anybody knows of pigging that you can do on pipes like that, I don't know. I know that you get for the electrical pipes, they have a little pig that they run through the electrical pipes to get the draw wire through. Something like that might work, but it could also get stuck somewhere along your pipe, and then you have a problem. You've got to find it where it is. But I'm quite sure that might even work, but it's for 20 millimeter pipe, so it's going to be too loose to actually push through, and I don't know if it's really going to work. But flushing, just a proper flushing of the pipes. Our water-soluble fluxes are good today, so they're easy to flush away, so it won't be too difficult to clean them. But don't wait for 2 months before you flush the system. Once you've installed the pipes or a section of the pipes, you've done one bathroom, put a hose onto the one side and flush it through, because your walls or your floors aren't in yet, so it doesn't matter if the water comes out the pipe. Then you know you flush that section of pipe that you did for that day, you flush it out nicely and clean. Then you've already done your due diligence as far as cleaning is concerned, and then it can stand for another month or two until you disinfect the system.
Okay, next one, must hot water pipes in concrete be insulated, or can we just sleeve them?
Hot water pipes in concrete, you can just sleeve them. Obviously, if you're going to put them, if you're putting a lagging around them, it could be damaged by the concrete as well. But if you're going to put them in a sleeve, then obviously inside that sleeve it should be lagged. So your sleeving would be, I think, if you're looking at 22 millimeter pipe and you're adding the thickness, I'm not exactly sure of the thickness of the lagging now, so you're going to look into a pipe of a sleeve of at least 75 millimeters, I would say. Then you can comfortably put it through with a lagging, because you are going to lose heat in a hot water pipe underground or in the concrete slab. So yes, you're not going to just sleeve it, you will be lagging it and then sleeving it. Very difficult to do, I know, but obviously you must try to avoid putting it into a slab if at all possible. But I know when you have these exposed ceilings, you just can't do anything else. And then sometimes that'll end up as a rational design, and you'll have to discuss it very clearly with the architect or the engineer doing that rational design. So yeah, it's a bit of work that goes into planning that. There's a lot of extra planning when you have to put it into concrete. So make sure that you're trying to stick with the standard and serviceability of that pipe if anything does go wrong in the future.